Further ado. Okay, everyone. Hello. Welcome to the wasmCloud community meeting for Wednesday, March 6th. We've got a pretty quick but pretty fun demo for the beginning of the call. And then we're going to do a check-in on the WRPC MVP and pretty related, the 1.0 roadmap, which is moving along pretty swimmingly. So let's go ahead and get started talking about the wasmCloud policy service. So those of you who have been running wasmCloud or working on applications locally, but haven't necessarily gone to the step of running a wasmCloud cluster in production or running it in a way that you are kind of administering a platform or just running code that may or may not be yours in your wasmCloud host. You may not have looked up or had the need for the policy service, but we do have a really great, a pretty flexible, pluggable policy service API for wasmCloud. We do have documentation around it. If you look up the policy, if you just look up policy with our search, it'll bring you to this page under production deployment guide for preventing untrusted workloads. Now we have a couple of things here, but the policy service right now is something that you can configure when you start the host. You basically give it a NATS topic to send out policy requests on. If you enable a policy server, then anytime you start an actor component, anytime you start a capability provider, or anytime a component invokes a capability provider, we'll send out a request on the policy topic to ask if that should be allowed or not. So this is an example of a way that you can extend the security of wasmCloud. This does include a cache so that you're not, sending a request for every single invocation. You kind of allow it, and then that is allowed until it is revoked. But if you turn on the policy service, then actions are disabled by default. So if you turn on the policy service and you have a failure to actually invoke that server, then you're not going to allow anything. For what I'm going to talk about today and show during the demo, you can really think of the policy service, if you're coming from a Kubernetes background, as an admission controller. When you go to schedule workloads onto your wasmCloud host, you can consult an external policy server to decide whether or not you're allowed to start that. So with wasmCloud, we have a basic level of validation to make sure that, it is a real WebAssembly component, that you've kind of packaged your capability provider in a way that is the proper way to package a provider, that you can execute it, all of those things. But this is a way to, like I said, extend the security of wasmCloud and introduce your own logic. So by far, at least from my research and experience, by far one of the most popular projects that people use to do this kind of admission controller or admission hook, basically policy evaluation for cloud native projects, is with Open Policy Agent. So if anything that I use here aren't exactly the right words or so for Open Policy Agent, please feel free to jump in. But what the big TLDR here is that it's a combination of a project and a rules engine, and a essentially policy evaluation language called Rego, something like that. So why don't I go ahead and, uh-oh, Bailey's smiling. I said it wrong. Why don't I go ahead and show you what this really looks like? Because I was actually able to whip this up pretty easily with the Open Policy Agent docs. So in one of my recent PRs to the Feat WRPC branch, is called Formalizing the Policy Service, which changed around some of the payloads in the policy service. But that is really just in the interest of 1.0 and us being able to make forwards compatible non-breaking changes. So the actual example, if you go, it is under the Feat WRPC branch, which we'll talk about here in a moment. But if you go under examples, we now have the security folder. with a single a top level README. We're going to be adding other examples here for other ways to extend the security of the wasmCloud cluster, or to visualize actually seeing the security checks in action. But for now, I just have the README set up for this one policy server example. And in here, we have a single folder called OPA. There are instructions here that I'm going to run through here in a moment. But this OPA server is actually a pretty generic Go binary that you could test out with your own policy if you'd like. All it does down here in main is connect to the default NATS URL, assuming you're running NATS locally, subscribes to wasmCloud.policy, and then anytime it gets a message on that, subscription, we evaluate the policy. Taking a look at what that really does, just for looking at how the OPA implementation works, we make a query on this policy that I have locally, that you have on disk, and we query whether or not the wasmCloud access is allowed. And then we do some nice Go marshaling, UID generation, error handling, and the key part really is here from the query. We make sure that this actual expression evaluated to be true, and then we permit starting the component or starting the provider. So this little test server you could use for your own inspiration. I think the real interesting bit here is in the policy itself. So I picked some of these names fairly arbitrarily, but we have the package is wasmCloud access. By default, this allow variable parameter query thing we're setting to false. And then, like I said, there are three different things that we call this policy server for. If it is perform invocation, what we're going to do is immediately allow that. This policy server is just interested in, I guess I didn't explain that. This policy explicitly only allows wasmCloud specific or wasmCloud signed artifacts to start in the wasmCloud host. So if it's one of the wasmCloud examples, one of the wasmCloud capability providers, we're going to allow it. And if it is not, then we will deny starting it. And you could use this, for your own organization, for example. So perform invocation, we're going to allow all of those. We're going to allow the requests to start a component or start a provider only if it has claims, which means the actual entity, the workload is signed, and it is issued by wasmCloud. And that's a really simple looking if statement where the input, which is JSON, making sure that the input has claims actually on that JSON map, and that the issuer on those claims is the wasmCloud public key issuer. So the policy itself is actually really simple to write. The Go binary is pretty simple to put together. So let me show you what it looks like to use. So I was looking up something else. If we run NATS server, let me zoom in a little bit, with Jetstream, which is just what you need for any wasmCloud host, then what we can do, I'll kind of split the terminal there so we can do a little bit more. I can run the wasmCloud host with a policy topic configured called wasmCloud.policy. Now this is running with cargo. I'm working off of the branch here, but you all can try this out. And this is actually present in wasmCloud 0.82. It's been around for a long, long time. So you don't need to be executing from this branch to try this out. Just using it because it has a different format. I think it's really easy to show. Okay, so we've started the wasmCloud host. Now what I need to do is let's go actually run the policy server, which is under examples security OPA. And you can build it just with go build. And then that comes out as this OPA binary. We can execute it. And then I just have a simple little print line that says, hey, I'm going to listen for policy requests. For one more, for your own edification, I will subscribe on wasmCloud.policy just to show you what this payload looks like. And finally, what we can do is let me go ahead and try to start an actor or start a component that I wrote. So this is something that I pushed up. I signed it with my own signing keys. If we not there, it is this. If we take a look at this individual actor, we can inspect it. We can see that it is a component, but the account key does not match. The issuer does not match. This was issued by me. We're not paying attention to the identity here, for example. But I'm going to send a request to start this component. So it received it. We got a message saying, hey, that looks like a valid request. We're going to go download it. But you can see here in the host logs that it failed to scale the actor because the policy request denied the policy server denied the request to scale the actor. If we take a look at the actual payload that we received on the policy topic, we can use JSON to take a better look at that. You can see that this request has a unique ID associated with it. The kind is start component, and we included all the different pieces of information for the component that we're about to try to run, and the host that we're going to try to run it on. So the policy server itself, you do have a pretty easy example for making sure that it's signed and it comes from an issuer that you trust. You can also possibly do some logic to make sure that it's coming from a set of OCI registries that you trust, or that it is being started from an OCI registry. We deny file loads by default, but you could have an extra measure in there just to make sure. You could use a policy server to make sure that you're not starting or scaling a component to a higher scale than you have configured or something that you've allowed. You could also use the policy service to make sure that certain resources are getting started on certain hosts. So if you had a component that was specifically designed, say, to take up more resources than a component that was meant for the edge, you can make sure that the label of the host or that there's a label on the host that's well equipped to run that workload. So different types of examples and inspiration that you could take from for what a policy server can be. That is kind of the point for why we've made it something that's extensible over NATs. Just applying it doesn't have to be wasmCloud.policy. You can subscribe on my org.123.policy. I'm making up a topic out of thin air. And specifically worth mentioning that this isn't tightly bound even to Open Policy Agent. Just interfacing over NATs and returning a payload that says, hey, this is permitted, optionally with a message is all you really need. To show you that this is actually doing what it's supposed to do, we can also tell the host to start a capability provider. And this one is from wasmcloud.azurecr.io, and it's our HTTP server provider. If we send that request, you can see that we are handling start provider, and then we actually did start the provider. If we look at the NATS message here, or the subscription, we can see that we did get a request asking the policy server it's allowed to start that provider. And because the issuer is the wasmCloud specific issuer, policy server said all good. It evaluated that rule and then got to go from there. So this is a pretty simple example of using, I used Go just because Go has a really good NATS client library. It has a really good integration with Open Policy Agent. But again, the only requirement here is that you have a policy server that can receive JSON over NATS and then send back JSON over NATS. You are actually, one of our previous examples used a wasmCloud actor with the messaging capability provider to receive that message, evaluate the policy, and then return whether it's permitted or not. So just wrapping up this example. I actually didn't mean to stop sharing, but I'll go back really quick. All of those requirements are detailed here in the preventing untrusted workloads section of the documentation. So we're making the request on a NAT subject. Here is the format of that request. And in response, just send something back in this format. The important part is the request ID and permitted. So that is an example of how you can use Open Policy Agent to increase the security of your wasmCloud cluster. Do folks have any questions for that piece?
That was such a good demo, Brooks. I think OPA is basically starting to become basically the industry standard for this type of work. And I love seeing anywhere where we are able to integrate with existing patterns. And yeah, I want to highlight the one thing you said, super extra good about how extensible it is. There's so many more types of policies that I think will be more standard going forward. I think there's a lot of things that we're going to add here and that other people in the community will add as this thing expands. What were you going to say, Liam?
Billy, that was actually going to be my question is, you know, so when I think through, what WASI means to me, it's taking POSIX, breaking it into these smaller worlds, threads and file IO and HTTP that I can now have as individual permissions. And we've got policies now over starting and stopping components here. What is the kind of broader vision here to kind of like be a little more tactical with your ask is, hey, there's lots of policies, would we have policies that span all of WASI? I mean, would you have how far would you take this?
Right now, the way that we do obviously secure by default, but then also interface-driven, capability-based security. So we don't give you the interface if we don't think you should have it. And so an example of that is where we stub things out, like file system and sockets. If you don't have a way to safely sandbox it, and wasmCloud's an application platform that allows you to run arbitrary user code, then don't let them run it, right? But let's say that maybe we do want to run variations of that is possible to make safe, right? Maybe you have some content security policy that allows you to hit certain domains and IPs. You could extend this in a way that we would be able to say, actually, you know what, this one's fine. We can admit this type of workload and start this type of component. And we have all the information we need to say exactly what that component needs because a component itself is self-describing by the interfaces that it requires. So there's just a lot there for that part. Then the second part here is there are other things in our system that we could report in on that maybe we aren't yet. For example, I would love to see it where we could have some long-running components. But I wouldn't want to change the timeout by default, right, for my whole system for all workloads. I would want to do it at kind of a workload identity or component specific level. And I could imagine building a policy that's specific to that. And that would be really powerful.
Well, that is powerful. And let me ask just one more question because I know we're down into like imagination land, but that's where I like to live, is there, unicorns and rainbows. When I think about, really powerful policy engines that have kind of dominated their space, I think about like Cloud Custodian, a multi-cloud, pluggable policy engine for cloud APIs, simple design, powerful integrations. Is that what we are kind of thinking about here, or like is that where the fog is starting to open up? Is that there would be some WASI policy engine that has a basic vocabulary. It lets you define policies like, type of value or duration, and then have them pluggable to WASI elements or properties underneath.
Our entire networking strategy now is built around WRPC, which I know Brooks is going to give an update on right after this, so I don't want to delve too deep, but WRPC communicates over the width definition. Basically, that's that interface that we're indexing around. I don't want to call it WASI though, because we support through WRPC custom interfaces, right? So it's not just WASI, it's interfaces, and you can come in at a very fine-grained level and define the types of capabilities that you want to allow in your system. And you're doing that in a way that is, based on existing tools that you're almost definitely already using, like OPA. And the other aspect here that I want to highlight, I guess, is that, it's not I know we often in WASI land liken it to POSIX, but it's pretty different because not everything's a file, right? In POSIX land, everything's a file. It's just a pipe. And, I have no idea what that thing is, but I know that I can take one pipe and plug it to another pipe and, it happens. That's how I can plug together programs and make them useful amongst each other. But we've learned a lot in the past 30 or so years. And when we're talking about WASI, we enable a lot of things that POSIX enables, but it's in a very fundamentally different way. That is obviously in this like interface defined, AKA if I have the interface, I have the capability type of model. And it's just so powerful because you can plug interfaces together for a long chain. So I could imagine even more complex types of policies that we could write that could even consider chains of these things, right? Because you're talking about compositions of components. But as Brooks said, when you think about the way that WRPC works and the way that wasmCloud works with WebAssembly components, we enable you to feel like you're composing components, but in a distributed way. And so you can come up with policies that actually recognize this like distributed nature, but also be completely compatible with this one giant composed component as well.
Okay, so you have a view and a vision that yeah, there's going to be some kind of like a Whitstodian, like policy engine that you can write around WIT data types so they can interface with things, but that there is also a broader comprehensive thing that might also include like wasmCloud labels. So you could do like location aware policies or other tagging. So okay, wow, that blows my mind. But
Right.
super.
Because wasmCloud enables you to do so many other different patterns beyond just component workloads. That's our unit of distribute, and that's cool, right? Like my unit that I'm distributing of my compute, I want to make sure it has the capabilities it needs and not the ones that I'm not able to sandbox and secure. But then also, I want my components working in concert with each other in a way that I'm enabling new types of software patterns like scatter gather over NATs. Like there are so many other things that this policy service enables for people to design around.
Okay, thank you so much for the for like engaging in some broad thinking there. Really appreciate that.
Yeah, I wanted to show one more thing because I didn't really talk about it today. In the demo around the policy service, I talked about the start component and the start provider policy evaluation, but not perform invocation. So the type of information that you get whenever a component is going to try and invoke something over WRPC. Right now we do it, or in the release version of wasmCloud, it's over WASM bus RPC, but will be WRPC. You get the exact interface and function being something like WASI HTTP outgoing handler and the function, which I believe is handle, not request. And this is just extra metadata, and then the exact target as well. So what component you are targeting, where that component was started from, how much of a scale it has. The really important thing for us that I want to just kind of wrap this segment up in emphasizing is that the policy service is a very minimal implementation with only the little bits of required information that you need to make a really wide variety of decisions with a pluggable API that you can just slot right into your existing tools. And I think that fits really, really well with the entire methodology that wasmCloud is using to approach other cloud native standards, using OAM for WADM, using OTel metrics, and starting with a minimal set of metrics so you can answer questions, things like that. So I think the policy service is a great way to integrate using, to add those existing controls that you may already have defined in open policy agent policies, and just slot that topic right up with this little example binary. It's all good stuff. We're about halfway through the call. I probably have some time for a question or two if folks have more they wanted to chat about. Alrighty, then I think we can go ahead and move on to the next section of the call, which is just going to be a check-in on WRPC. This has been certainly the talk of the town for the last couple of community meetings and in the wasmCloud Slack. So I'm pretty excited to see how folks have been following the progress of this. We do have an issue here, which I'll go ahead and send in the chat just in case. Get out of here. Just in case folks want to take a look for themselves. But Victor and I have been kind of going through, adding comments, and checking off boxes around the things that we're doing for the Feat WRPC branch. Idea is that once we check all the boxes here, or at least most of them, because I know that these don't need to be done, we will merge that branch into main, and then have something that folks can try in the community. So just to give an update on where we are, we've done a ton of the above. We've done a ton of work here around refactoring, getting components and interface links set in. The latest advancement that is going to land a little bit later today is this PR from Victor, which is a huge amount of work. But what this does is takes the current provider SDK and WIT bindgen macro, and actually instead of generating handlers for WASM-Bus RPC, which it already was doing from WIT, enables you to generate types, like I said, that it was already doing, and handlers for WRPC. So when you write a capability provider with a provider SDK that's in this PR, it will actually subscribe on the WRPC topics, do the encoding of those types so that you can send and receive them, encoding and decoding over the wire. And what we actually have with this branch is the very first example of a component invoking a provider over WRPC. I think we did it with our key value Redis provider to start. So this is really exciting stuff. Once this merges, essentially the work that we have left before we merge that branch into main is going to be restoring some of our integration tests. And it's going to be updating the contracts that we use to be 1.0 ready contracts. So we've done a lot of thinking around our common contracts with things like key value and blob store and messaging, HTTP, but HTTP is the WASI one. And so we just need to, when I say we just need to, the work there is updating our providers to be based off of those contracts, which, since we have the WIT bindgen macro, you're able to do any custom interface in, asterisk, you're able to define your own custom interfaces and generate provider types and handlers from that. So essentially what I plan on doing is taking this branch, playing with it on my own for creating a provider from scratch, and then making an example or two or three out of it with the help from other folks on the wasmCloud team, so that you can generate providers, you can update your own providers, things like that. I know that there are people on the wasmCloud community side who have already started writing capability providers from the WIT bindgen macro, even though it hasn't been published yet, which huge kudos to y'all. The great news is that it's kind of just an update to give you a look behind the scenes. Sorry, I keep sharing and unsharing. We're I keep thinking of new things that I want to show folks. If we take a look um, at one of our capability providers, like the Blob Store provider, you can see that the amount of code that providers actually need to change is really, really small. Like nice, we changed to do comment here, but really all we're changing in the provider is going from the previous structure of a link definition, which was like a bidirectional, to an interface link definition, which is a link on a specific WIT interface. And then when you're creating a capability provider, we now have the notion of, is the provider the source of the invocation or the target of the invocation? Other than that, none of the actual code so we have some changes in logic for put link and delete link, but there was no code that actually changed with the way that the business logic of the provider worked. So all of that stuff is great. So folks who have already started with the provider SDK and the WIT bindgen macro shouldn't see a ton of changes there, but I'll make sure to detail those as much as we can. Okay. Wrapping up the WRPC segment, just want to set expectations that you can expect to see this branch merge into wasmCloud or into wasmCloud main, likely tomorrow, but by the end of the week. And at that point, once we have all the pieces in place, we're going to take a look at the rest of the roadmap. And then once we can merge those critical pieces over, start cutting release candidates for 1.0. So I'm working on the side of updating Wadum, and we'll be updating Wash as well, essentially to give everybody developer alpha, beta, whatever phase you want to put that under releases to play with as we lead up to the 1.0 release. Any folks have questions on the WRPC MVP integration?
Are there any asterisks you want to call out right now for what you can do with a custom interface
Oh, yes.
specifically?
Thank you. I didn't mean to just leave that out in the open. So for 1.0, the WRPC protocol does have support and planned ways to implement features that are not currently in WASI preview in a WASI P phase. So in WASI P2, the functionality around futures and streams, those are actually, I believe, going to land in WASI P3. So we already do know a way that that is going to work, but since it's not in the in P2 or 0.2, Bailey, jump in if I get any of this wrong. We don't have to make it work right now. The big caveat around custom interfaces for wasmCloud 1.0 is around resources. So with resources for components, a resource is essentially a specific, I like using file descriptors as an example because I think it translates pretty well. One component could have a resource, which is a file descriptor. And if you get information on the file or write to the file, you're manipulating that one resource, which is like a overload, a resource on the host system. Now, if you have a distributed component and a distributed component wants to manipulate that resource, it has to do a network call back to the original component, the one that owns that resource, to manipulate the resource there. Sorry for overloading. It's just too easy to say resource. Because of the complexity of that, and because it may be easy to get yourself into a place where you're doing a bunch of inefficient calls with resources, and in order to help us scope for the 1.0 release, we're not supporting resources in custom interfaces right away. This does mean that you can define your own types, you can use records or enums or structs, you can use variants or enums, you can use lists of enums of structs. Like you are able to use any of the WIT simple and complex data types. It's just if you are implementing a WIT interface or a WIT world and it has futures or streams or resources, please reach out in the wasmCloud Slack, and we can help design a couple of ways to make that into a custom interface with concrete types. That is the big asterisk around custom interfaces. Now, we do have a few interfaces that are going to use resources like WASI HTTP. And for those, we are specifically programming on the wasmCloud side. So you may be able to see an example of how this would work. But that's the asterisk for 1.0.
So there's some I just want to talk. So I'm just going to talk about component modeling things because there's a lot more I wanted to say there. So we do have a WIT type in std.io, or not std.io, but the equivalent to std.io, wasI.io. And so that does have, stream support, so you can do async things with components now. But what we're saying is for custom interfaces, there's a lot of work for being able to generate the right bindings on both the host side inside WASM time and then on the guest side. And, it makes sense to issue that feature initially out of the gate. And we do expect some of that area to change as we add native async for P3. For resources, one thing I want to call out about resources is that the idea behind them is that they're a thing that has a lifetime. It has a constructor, it might have a destructor, and so I would say that a best practice for if I'm trying to define what's a good custom interface that I want other people to rely on, if I'm creating a capability provider or a component, is generally speaking, even if we had resource support, I might say that it's a little bit of an anti-pattern to provide that, because what you're asking for is lifetimes added distributed scale. And while we will make that work, I think what you would want to think about is, hey, in the 12-factor app manifesto, you need to expose things in a way that allows people to have CRUD operations on your resources, overloaded there, I should say data. And so today, I would say the best practices is like, hey, I do want to define a resource. It's part of my WIT definition. But the thing that I expose, aka export or import on my interface, or really the world that I'm defining, it should probably have those CRUD operations for how to interact with that resource, but not actually exposing the resource directly. And that's and the other aside here is that resources, like you said, a file descriptor. Let me give context for what a lifetime looks like for that use case. So I open a file descriptor, right? And I've opened it on some system somewhere, right? And it's a file descriptor, so it needs to be on that system where it's applicable. And so I have a lifetime now, right? It's now I have an instance of this thing. I'm pointing to the specific set of data. With resources, you can pass around borrowed handles. So you can kind of be like, I don't actually own this thing, I just know where it is. I think we can go with some really great stuff for distributed use cases for that. But when you start saying, actually, now I'm going to take an own, what you're saying is I need to take that data from this other place, and now it's mine. And so that's kind of what Brooks is saying about how you can kind of get yourself in a weird spot, especially if you're using a resource to define a set of CRUD operations on it. And those are things that you're going to frequently call. You're going to be going over the wire for that. So when you're designing your interface, design it like you would kind of define any other modern piece of a service. Is that resources are yours, and your component gives other people a peek into the world of how to work with it.
Thank you, Bailey, for diving in and giving so much better worded context around that. I really like that example around how you can still make use of resources in your application in your world, but the actual transmission over the wire is something you do with a very specific API. I think that makes a ton of sense. And now that I'm thinking of it, it calls out a nuance, but an important one that you can still, this didn't even click in my brain until right now. You can absolutely still use these concepts in a component or with a composed component. It's just what you're sending over the wire that needs to be concrete data types.
Exactly. So when you're thinking about what my custom interface is, the thing that I want other people to expose, that's when you are thinking about it at a distributed level. And you should be thinking about it at a compositional level as well, right? That got interesting and tricky real fast when we were designing things with WasmVert, for example. And Guy Bedford gave a really nice intro on that during the WASM working group for the CNCF earlier this week. So you can check that out on YouTube where he walked through it. But even in that case, when you're dealing with things like streams and resources, these are sort of like kind of stateful bits, and you have to have a table that knows what the state is and keeps that up to date. And when you're thinking about what's a good interface, ultimately what you come down to is where's the data and how do I expose it in the right way?
I think we're going to have a really great opportunity. I know I have this in a backlog or on my to-do list or on a sticky note under my keyboard or something, to write really good documentation around you have a component, when to compose that with another component, when to use WRPC. I think that we've got a lot of good, a lot of great knowledge around good ways to do that, and we just have to share it. Hey, folks, questions on composing components, WRPC? All right, well then I will jump into the last section of our regular community meeting, which is our roadmap update. It's getting pretty exciting, getting closer and closer here. So if we take a look over at the completed column, I know that I've called this one out, the deprecated WASM Bus EVT one, as a good first issue. And when I was in the code modifying some events, I saw where we needed to make the modification. I just went ahead and took care of that one. So that one moved over to the completed column. I've also, where is it? There it is. This RFC is actually still open. I did something a little weird, and folks can feel free to object to me on this one, and I will defend my decision. I moved the WIT support for wasmCloud, the WRPC, over to the completed column. And the reason why is the title may be a little bit misleading, but this RFC is really all around the WRPC protocol, the implementation, the crates used, getting the transport working. And so that bit of work, which was largely implemented by Roman with a set of crates that are now in the WRPC branches dependencies, actually implementing the WASM or the WASM transport over WRPC is something that is completed. So I went ahead and moved this for the purposes of the 1.0 board over to completed. There is more to do here, like we were talking about around resources, but I plan on getting an ADR or getting, whether it's Roman or one of us to get an ADR to close this RFC out because we've accepted it. We're using WRPC. It's how we're doing our transport, things like that. I guess I'll pause because democracy. Do folks have objections to this technically being opened but being done in terms of the 1.0 roadmap?
I'm in favor.
Thanks, Bailey. That means we're doing it. All I need is one positive affirmation and it's done. To further continue my evidence there around what's in progress, there's still obviously work going on around WRPC, around fully transforming our host and our tools and our libraries to use componentized links with WRPC, and around the MVP integration, which of course there will be post 1.0 work for WRPC, not just for polish, but for additional features, et cetera, et cetera. Once these are complete, which is the goal of the Feat WRPC branch, We will be pretty free to take on remove capability claim signing, which we've already removed as a requirement in the host. So this is just like in wash in our wasmCloud.toml, not requiring that. Pinning our WIT definitions, which is around like our providers, blob store, messaging, key value to 1.0. And then evaluating this last effort in the blocked column, which I've gone through. I think if you look back at old community calls, we had a few other RFCs in here, which I've gone through and either moved forward or descoped for the 1.0 milestone. I want to give a huge shout out on 1551. Wait, where is it? Never mind. There was a different issue that somebody took in the community that does not apply to this. I thought it was the same. Never mind. But this one, this add label updated and label deleted event, which would be a good one to put in before 1.0, which is just making sure that, things that are observing a wasmCloud host can, like Wadum, this is specifically for Wadum, can reevaluate if it needs to run workloads on a host or not based on if a label is added or removed, which is something that we have support to do dynamically. I went ahead and set it, so why don't I go ahead and give my shout out anyways. Wanted to thank, where is it? On this issue, the wash labels support multiple key value pairs. See, I was in the right place. I didn't get it totally wrong. I was thinking about labels. Thank you to Hanshaw for taking this issue. Going to be working on and I really like this method of collaboration of like, here's the code that I was thinking I would use. I'm a big fan of stuff like this or draft PRs, even if something isn't fully completed, just be like, hey, this is what I'm thinking about. Am I on the right track here? So thank you for taking this issue. I think this will be a really great developer experience improvement for the wash command line, being able to label hosts with multiple things at the same time. So good old community shout out. Okay, I've strayed a bit from the roadmap. Do folks have questions on the 1.0 roadmap? All righty. And I think that's it for our regularly scheduled agenda. I think we've got a couple of minutes here at the end. If folks have any questions, comments, things that they'd like to bring up, general in wasmCloud or from the broader Wasm ecosystem, I'll just go on mute. Just taking a look at the calendar really quick. I will say that next week we will have our regular community meeting. That will be the day before the WASM IO conference. So some of us will be already in Barcelona, but I should be well and available here for WASM Cloud Wednesday. So that's on the 13th of March. But the following week, which is the 20th of March, just a heads up, that will probably be a pretty light community meeting. It will probably, historically, we've tried to do this. It'll probably be from the conference floor in Paris, which will be pretty fun. That's always just a shorter community meeting. I'll try to shout out some of the cool things that we see. If I'm lucky, I can get a representative from like NATS and OPA and OpenTelemetry to come like high five me on all the integrations and stuff. That'd be pretty fun. But in general, just a heads up on a couple of our future community meetings. All right, folks, then I'll go ahead and stop it for today. But thanks for coming to the community meeting.